Hey guys, and welcome back to the 7th episode of the Magic Shooter tutorial. In this episode, we'll be incorporating models and animations into our game so that it looks much nicer than just a pill running around. First, we're going to be replacing the capsule player with a model that we provided that looks much better than just a capsule. Find the XSpot model in the Models folder and drag it into the hierarchy. Rename it as Player. Give it a capsule collider and a rigid body. The capsule collider should be centered at 0, 0.9 and 0, radius at 0.2, and height of 1.8. On the rigid body, you want to set the drag to 2 and freeze the X and Y rotations. It should already have an animator. The animator is a Unity component which helps us manage animations and their transitions. In Animator, uncheck Apply Root Motion. Root motion is a form of making animations, but we won't need it. Change the tag and the layer to be player. We can drag the player controller component from the capsule onto the new player model to save all of the information that we had before. Delete the old player prefab and make the new player into a prefab. You can delete the old capsule now and update the main camera so that the player transform in follow player is the new player. Now that our model's set up, we want to put some animations on it. We won't be creating animations from scratch. We already have some ready to be used. But if you're interested in learning more about animations, I'll put links in the description that you can look over. We'll create an Animator controller in the Animations folder, and we'll name it Player Animator Controller. To look at the animator, go to Window and click on the Animator window inside Animations. We want to create some states for different animations: laser casting and movement. We can do this by right-clicking on the main area and creating an empty state. We'll name the first one to Movement. As you can see, it goes from the entry state, which is the start of the game, directly into movement. We'll create 2 more states, one for each magic ability. We'll name these Laser Casting and Mega Laser Casting. We want some transition between movement and each of these laser casting abilities when we're in the game. To create transitions, we want to right-click on the state and select Make Transition. Use your mouse to connect movement to laser casting and the other way around. And we'll do the same thing for Mega Laser Casting as well. To trigger these transitions, we're going to have some variables that will help us transition between the animations. The variables are on the left, defined as parameters. Here, we can have a few types, including floats, bools, and triggers. Let's create a new one by pressing the plus button and selecting float. This will be for speed, so we know how fast the animation needs to be running. We also want 2 triggers for when we want to shoot each type of laser. Triggers are one-time calls, kind of like a function. We want to make sure that these are the same name as the triggers that we set up before in player attack info, because this is how we'll call the triggers. The movement state is going to be a blend tree, which allows us to blend together animations to make things like movement more smooth. To set it up as a blend tree, right-click on movement and select Create New Blend Tree in State. To go into the blend tree, double-click on movement. The movement blend tree will be determined by how fast the player is going, which is why the speed parameter is what will define the blend tree state. We'll have 2 main movement states, idle and running. Create these by hitting the plus icon in the inspector or right-clicking on the initial blend tree and adding a new motion field. This is where we want to set the actual animations. To select them, click on the circle next to None (motion) and select the idle one for idle, and we want to set the running animation for running. Now, we want to assign animations for laser casting and mega laser casting. Let's go back to the base layer of the animator. To add animations into the different states, we can just click on them and attach an animation into their motion parameter. For both of them, we're going to be using the same animation, magic spell casting, but we're going to be using different speeds. For laser casting, we're going to be using a speed of 2 and 1.75 for the mega laser casting. Now that we have our animation set up, we want to be able to transition between them. To edit the transitions, click on the arrow between the 2 states, and it should highlight it in blue. We're going to start with the one from movement to laser casting. For this, we're going to uncheck has exit time because we're going to give it a few conditions. In the condition section, we're going to use one of the triggers to activate this animation. Click on the plus icon and change the parameter to shoot laser. This means that when shoot laser is triggered, this transition will happen and the animation for laser casting will begin to play. For the transition back into movement, we want the laser casting animation to play out all the way before returning to movement. So for laser casting to movement, we're going to keep the exit time. In the settings, we can adjust how long it takes to finish and how long it takes to transition back into movement, but for now we'll keep these at the default. We can repeat the same process for mega laser casting. From movement to mega laser casting, we want it to be triggered by shoot mega laser and not by exit time. And from mega laser casting to movement, we want to use the exit time for the transition. The next step is to actually trigger these animations and transitions. In our player controller script, we're going to get the animator component of the player. In cache references, we're going to make a variable for the animator, and in awake, we'll get the component from the game object. In update, we'll set the value for the speed parameter in Animator. This combines the forward and right velocity to see which part of the blend tree we're in and if we should be in idle or running and how fast we should be running. The clamp 01 means that it will be limited to a max value of 1 and a min value of 0. We also need to set the animation for whatever attack we're using. In the use attack coroutine, we'll set the trigger of the animation, passing in the attack name that we gave the attack and the animation. Next, we want to allow the model to change colors a bit, and we'll be doing this through code. First, we're going to initialize our variables. We're going to want to keep track of our player's current color and our player's renderer, which displays and controls how the model looks in-game. Notice that the player's children have skinned mesh renderers. We'll be accessing these to change the color. In the private variables region, declare the default color variable. This will keep track of our default color, so we can switch between multiple colors and always revert back to our default color. In the cache references section, declare a cache reference to the player's renderer. In awake, initialize the two variables. Our renderer variable will call upon the renderer components of our children, and the default color will just be the color of the material from our renderer, since this is a color that we start with that we want to keep track of. To change the colors, we're going to create a coroutine that changes our player's color from its original color to the second color that we give it. The coroutine will take in a new color and the speed that you want to change it at, which will be a value between 0 and 1. We'll grab the current color by calling cr_render.material.color, so we know where we're starting the transition from. Then we'll create a while loop that will run while our current color is not the target color. Our coroutine uses a lerp function to linearly interpolate from one color to another to make the color transition smooth. Normally, lerp is just between two values, but color.lerp is made specifically to transition between colors. The t value is going to be our speed variable over 100. Then we set the color of the renderer to that new color. After that, we want to wait until the end of the frame before we run the loop again, so we'll call yield return null. If we don't wait, then it'll run too fast to be observed well. Now, in the use attack function, we will start this coroutine at the start of our attack to change the joints of our body slowly to the color of our attack. We set up the variables of the coroutine before actually calling it. When the attack animation is done, we're going to stop this coroutine and start the same coroutine again to change our player's color back to the default color. We can stop coroutines by calling stop coroutine, just like we did with start coroutine. There are some other variables that we should change now that we've changed our model for the player. In the main camera, we need to change the offset to -1.5, 1.5, and 0. The offset for the lasers also needs to be changed. The normal laser is now going to be 0.4, 1.1, and 1. And the mega laser is going to be 0.4, 1.2, and 1. Now we can see that our player runs around with an attack animation. And the attack looks much better than before. Our game's starting to look a lot better now. As a recap, we set up the animations in the Animator, wrote code to control the animations, and integrated everything together. In the next episode, we'll set up a health system and work on some UI. Thanks for watching, and I'll see you in the next part.